Hello everyone, welcome to AI Anytime channel. In this video, we are going to look at MatMul-free language modeling. So MatMul is a short form for matrix multiplication that is often abbreviated as MatMul, which is a fundamental operation in many neural networks. It involves multiplying two metrics to produce a new matrix. And if you talk about transformers, most of the transformers mechanisms are heavily based on matmul or the matrix multiplication. Not a new concepts when it comes to exploring matmul for language modeling. It has been there. We have been looking at novel architectures, but in this video we are going to talk about scalable matmul free language modeling. So I'm going to cover a research paper and also going to explain that how we can look at the alternatives when you want to come up with novel architectures for language modeling, if you want to scale, if you want to become more efficient, so on and so forth. So let's look at here on the screen. If you look at, I have a research paper that's called scalable matmul free language modeling, and University of California, the folks there, they have created, like, come up with this new methodology when it comes to language modelings, and that's a fantastic research paper. I wanted to cover this up. Also we'll break this down in different components and see how this can really help us in near future. So this is a paper that you can really read. I really liked it and just wanted to cover it. So as I said, matrix multiplication, we're going to talk about this model by Ridger. We're going to take this model as well, and you can see I already have run it, but I'll just walk you through. But before that, we'll cover that up. We'll see something, the basics of matrix multiplications, how this can be used in language modeling, and what the different alternatives that currently we use and how this can help with GPU optimizations or FPGA hardware and stuff. So we're going to cover that as well. Now, first I will go on uh, first I'll go on explaining the basics, and you can see I have my notes here. Okay, so we'll cover from basics, the layman terms. This video is for anyone who wants to understand matrix multiplication in language modeling or in neural nets. So we're going to cover that up. And the first thing that you can see, I've written here MatMul-free LM. Okay, it the simple definition here is that involves multiplying two matrices to produce a new matrix. So that's what it is. Okay. If you are someone, guys, who has no idea of AI and transformer and stuff, this video is not for you. So not waste your time, learning this. But if you are someone who has basic understanding of, excuse me, understanding of transformers, then you should watch this up. Now, matrix multiplication have been used in neural networks, guys. Not new. We have been used in layers such as layers. So I'm going to write it over here. Layers such as dense, which is a fully connected layer. We have convolutional layer. So if you have worked with CNN and stuff, you will know that, or even if you worked with ANN, you will be probably aware of a fully connected layer. When you talk about the newest architecture, like the based on like language models which are based on transformers. So if you talk about transformers, this has been used in the, so I'll just take a different color here to explain this part, in self attention. It's self attention. When you compute the attention score, it heavily relies on matmul, which is matrix multiplication. So we have to be aware of this basic thing. So if you look at here what I have written, matmul free language model involves multiplying two matrices to produce a new matrix, and layers involved are dense, convolutional, and when it comes to transformer, the self attention one. Now let me show you a couple of things here. So it's very simple. You need NumPy. If you want to do it programmatically, you can just do import NumPy as NP, and then you can define different matrices, and that's what we're going to do. So you define through array. So I'm going to have an array, basically a numerical representation going, you can see here different list, excuse me, I don't know why it says copy. So I'm going to have, and then I'm going to have something like this, that makes sense. And then you can have a B. So same way you can have a B, and then you're going to have a, like you just do a dot of it. So you're going to multiply this. So I'm going to just do np dot dot. And if you look at here, AB and print C. And same way, if I have to just do, I'm going to say just like, for example, X. So it also provides you this, guys. So if you look at this, the same thing. So you can just multiply like this. So this is how you can also do that, the multiplication. I'll just bring up my tab here so you can explain the tab. Yeah. Okay, so this is one. Now this is how simple you can just do with NumPy. I'll go back to my tab here and I'll just start with again. Now if you look at self attention, it is basically used. So it's basically used here in self attention to compute. So I'm just gonna write here to compute the uh, attention score. So compute attention scores. That's where we use the MatMul in that. Now there are challenges. So if you're going to talk about the challenges, let me just write it here. The challenges. There are challenges associated with it, guys. Transformer based models, they really rely on MatMul. And so if you if the model scale, now it already has, there's a law of scaling when in 2015 when transformers like surpassed it. People believe that bringing up more layers in transformers will not help them with the larger models, but the researchers have proved it wrong right now. If you look at the challenges, the when the model scale, so when the model is scaling, when you have to scale the model, your memory uses and computational cost also goes high. So you have your memory uses and the computational cost, they all goes high. So these are the bottlenecks that you see. This is the bottlenecks, and that's why we have to see, can we really use matrix multiplication free language models or MatMul free language model, because we have been talking about one bit LLM, because we have been talking about one bit LLMs, but just for your information, it's not usable. You can't use that. It's good for research and academia, but when it comes to using it for your research purposes, then that's a problem. Okay, so that's why, guys, I think it's important to first understand if these are usable. Now, so scaling further, if you want to make it a more efficient, then you need these things. Now, how do we can try it out? Like look at the example of self attention. I created a probably a gist. If I can just take that gist and show it to you guys here, I have some gist just to save some time. We'll put it over here. Now, if you look at what I'm doing, I'm using Torch and I'm using Torch neural network dot functional. I'm importing this module, and then I'm having a simple self-attention example. If you look at here, I have Q, K, V, and then I have the scores, and I'm using torch dot. So torch also provide a matmul function where I'm passing Q, and then you have to take the transpose of K, and I will explain that ternary weights in a bit. And then I'm calculating you're also getting the weights where I'm just using softmax function, for the weights, and then output where I pass the weights and the V, and then I'm returning the output with this self attention. If you are versed with transformer, I will recommend you watch the Andrej Karpathy's video on this. If you want to understand transformers, he has coded the entire GPT and GPT-2 with that. So you must watch that. And then I'm using some random value. You can see it over here, assigning it out, and then I'm calculating the output. And when you run this, you get a bunch of output, the tensor value over here, the numerical representations, as you can see. When I print the output of taking the self attention of Q, K, V, there are different, projections, layers, and stuff that you'll find out. You have to read that to understand a bit better. Now, this is also, it heavily relies, to compute the scores if you use transformers, and that's why there have been different approaches when you want to find out a novel architecture. So we talk about the challenges, and these challenges kind of limits it out, and that's where we bring up the MatMul free language modeling. The paper that you see here, you can see scalable MatMul free language modeling. When I talk about it, how the author has kind of suggested some new methodologies. So let's see that. So we'll just write intro to paper, and this is what I'm going to write here, intro to paper. Now they are talking about they have proposed a new method, to eliminate matmul operations in large language models, without even sacrificing the performances, which is important. So they use techniques. So what techniques they use, and I'm going to cover that. They use technique like bit linear layers. So I'm just writing it, bit linear layers, and they use this with something called ternary weights, which is really fundamental. So let me just write it over here, bit layer layers with ternary weight. I'm just going to write it over here, ternary weights. Now, this basically transforms MatMul into simple, addition operations. So they basically eliminate that. So we can, I'm show the difference between a traditional MatMul operations and a ternary accumulation. Basically, this kind of accumulation. This part that you see, this is nothing but something called ternary accumulation. So I don't know why this is selected. Okay, so I'm gonna write ternary accumulation. That's where the author focuses on. They focuses on MatMul-free dense layer. So the dense layer that you have when you define your neural networks, all the layers, and that's where you can go with excuse me, uh, bit linear layer with ternary weights, and we're gonna talk about it. So ternary weights, what do we mean by ternary weights, guide? So if you value, you know, anywhere like this as a weight, I consider between 0 and 1, but I'm saying ternary weights, I say -1, 0, and +1. So this becomes my ternary weights, and these weight transforms the multiplication operations into simple additions and subtractions. We can go a bit mathematical as well, but I can do that. But for you to understand, you have to understand what author has proposed. You can go through their you know you can go through their research paper to find it out. Even if you look at mathematically, if you look at the research paper, uh, excuse me, let me just, okay, and I'll take a new one. So I'll just take a new one. I'll just make this. Like, now, if you look at here, even mathematically, so it's not, it's very simple that it basically transforms that into addition and subscription. So this subtraction. So this is how you define it. It's pretty easy. Then you say tj of 1, and then you just define weight of ij, and where your weight ij is nothing, you have xj and weight of ij, then weight ij becomes your ternary weights. So this weight ij that you see here, this is nothing but becomes your ternary weight. This is what it becomes. You can I think you should write it from -1, 0, and 1, but this is how you can also define the formula of bit linear layer with ternary weights. Let's have a look how we can probably, I can show you here. I have a gist of that as well. We'll go through it. I call it bitlinear.py. So let me just copy this. Now, if you look at this code here, let me just paste. We again using NumPy for numerical computation, and then I have a bitlinear forward function which takes x and then takes weights as an input param, and getting the zeros of all the x that you have. So you can see zeros like using np, it gives me an output. Then looking in it and saying for I in range length of x, which is x, output I, getting the sum of it. So if you look at the formula, that's what we're also doing in when I was showing it, the summation of x into weights I, and then getting the whatever ith value you have, and then just return the output. So what I'm doing, I'm getting an x here. You can see a ternary value np.array, and then I have a weights, and weights I'm using np array. You can see it here, see it over here, and then I'm using that function passing my x and the weights, and I'm getting the result. So let's run this. And if you run this, you get 0, -2, and -2. So there's a lot of difference. If you compare that with matrix multiplication and without matrix multiplication, if you want to define layers within your neural networks, you can really improve, the efficiency of it, which is really important, guys. I think that's a, but then you have to figure it out if this is usable, in like in real world, if that is usable. If that is not, then it's a problem. Now, research is still going on, but these are good topics for you to start exploring if you are someone who is looking at AI research and you want to do some research. I think these are the areas you can focus. You can focus on the novel deep learning architectures on how to efficiently train and inference large language models. Now, what else they have recommended apart from this? Okay, so I'll go back to my notes, and here in my notes I'll talk about it. So the author also has talked about GPU implementation, that how should we implement. The one is GPU implementation, and third one is FPGA uh, optimizations. We're going to talk about FPGA, but on the GPU implementation, if we talk about GPU one, so let me just write it here. They are talking about the author provides GPU efficient implementations that, and if you look at the research paper, I have my notes. It says 61%. So the way they say it is one which is fused operations. So they recommend fused operations. The number two is kernel optimizations. I'm going to write optimized kernel. So in the paper, they have talked about kernel optimization. So I think this is also a very good topic, guys. You should learn about CUDA and different kernels and how to optimize it. Basically, if you're a good C programmer, I think these are the area you'll really love it. And then you have memory efficiency. So let me just write it here. Memory efficiency. So these are the three things he has talked about. Now, fuse operations are really fundamental. I mean, it's not rocket science. You can have a single fused kernels. So you have a single fused kernels that the GPU can execute them more efficiently. Now, if you fuse that, this reduces the overhead of memory transfers between different parts of the GPU. You have different parts of the GPU, which is like a bottleneck, for the neural network training or even the inferencing. Optimized kernel again, you people who are expert, I'm not an expert, but people who are an expert in this field, they also, I know a few of my friends who are kind of, they create specialized kernels. They design these specialized kernels, that are designed to handle ternary weights, because right now not all kernels can handle ternary weights, -1 0 and +1 and bit linear layer. So I think then you have to design these kernels, and that's why Nvidia is amazing, in these things, not only on the building the I think they build the entire ecosystem for Gen AI, guys, starting from the hardware to the software as well. Now, these kernels are, that they are tailored to perform ternary accumulation, which replaces traditional matmul that we are talking about. So I think optimized kernels, fused operations are important. Just the ternary when you have ternary weights, you can just follow on the bit linear layer. You can just follow simple addition and negation operations. This not only reduces computational complexity but also lowers the memory footprint, which is important. And the last one, if you do the first two, memory is like, it's like it will happen, which is eminent. You have the memory efficiency. So that's what it talks about, guys. And we're going to talk about, probably, I don't know if you we can also talk about the FPGA thing, which they say custom FPGA. I'll just write it over here. Okay, so they also have proposed this. So they have proposed bit linear with ternary accumulations, bit linear layers. Then they have talked about the GPU efficient implementation, and they have talked about the FPGA. So in the FPGA, they haven't talked a lot, but it's about custom FPGA hardware. I think I'm not gonna go deep. This part is not my expertise at all, so I'll just not talk about it. But so they have talked about this thing, guys, and I have something on the FPGA as well. Let's have a look at this function. I just got this from somewhere. I was reading an article related to FPGA. So if you look at this, it says pseudocode for a simple ternary multiplication and apply to matrices. So if the first function, which takes two value A and B, and we are saying if A equals 0 or B equals 0, return 0, and then have some conditionals, return 1, else return -1, and then I have apply to matrices. So if you run this, and you can just, again, you can use that to return result if you want to do that, but this is not our main thing. The main thing it wanted to show you is how you can try it out. Like, there are some libraries, so you can go to this GitHub. Let me just show that here. So if I just go here, on this screen, on here you can find out implementation of MatMul-free LM. Okay, in this implementation of MatMul-free LM, you can see already it's at 2.5k stars, which is fantastic. This, and they talked about all the things that we discussed, ternary accumulation over here, you can see some examples. We have matrix multiplications. We talked about scaling law, and we talked about these things. You can see they have some pre-trained model that you can utilize it. And I'm going to utilize the 2.71 model that you see. And this is how you can use it. They also have shown it. So you can follow this GitHub repository. I really liked it, and I think you can try it out and let us know your feedback. Now I'm gonna install. So you can see I already have installed from source, and then I'm using tokenized parallelism false. I'm just doing it false, and then I'm importing. I'm just using the same auto model for causal LM and auto tokenizer. So you can just do that as well. And then you're gonna load the tokenizer. So you can just load it, and you can just load the tokenizer to. Let me just bring up my screen here. Cool. Now let's just get the tokenizer, and you can see we've got the tokenizer, and then you have the model. So you can see the model over there. It downloads the model starts. You can see its size is anywhere around like 5 GB altogether. If you look at this model, so 5 GB, and I'm using CUDA and half. You can see, and then I already have it, and then I'm not going to run. And then I have an input prompt. So keep this in mind. It's a base model, so you cannot use this as an instruction tuned model for basically have question answer. It just complete the sentence. So that's why if you look at here, what I'm doing, I have an function where I'm taking an input prompt, and then I'm of course tokenizing it. So you can see I'm having the IDs, input IDs using tokenizer, and I'm on the CUDA device. I'm on a consumer GPU, and then have an output. I'm getting the model.generate, passing the IDs maximum length. You can increase this if you want. And also let me just increase as 150, and you have a couple of inference parameter, and then we have we're just decoding that out here. You can see it over here. So let me just run this, and as an input prompt I'm passing AI is a new technology. So you can see Q input prompt, and so let's run this. And when you pass AI is a new technology, and you can see it will give you result, basically it completes that sentence. So it's not like you can ask questions, really questions like an instruction based model, like which further fine tune for downstream task, which is not the case. And you can also do NVIDIA SMI to kind of check the compute. I do have, you can see you can below you can run it. So the issues with these kind of models, guys, okay, you can see it has completed, says AI is a new technology in the world and it has been used for many years. I will just make this a bit bigger so you can read this. It says AI is a new technology in the world and it has been used for many years. It can be seen that this tool was not developed to make money but with an aim of making people's lives easier by providing them information on their health, education, or any other things they want, blah blah blah. And you can keep going. The director general. So something like, you can see it's like relevant out of context somewhere, so it's like learning from the trained data that it has. So that's my problem with these kind of models, guys. They are not usable. You cannot really use this in like, for the different use cases. Let me ask this. Uh, let me ask something else. Okay. Mm, cryptocurrency is a scam. Okay, so I'm just doing something. If you guys are crypto lovers, excuse me for that. I'm not an expert. I think people are saying it's like a scam and all, and a lot of news. It has some it has some values, in financial transactions and here and there. But then, people who are like they do scams, they kind of use crypto to do all the scams. But yeah, you can also run the below function to check the memory uses, allocations, and everything. If you can kind of close here, you can click on here. You can also find out all the consumptions of your resources, and you can see it has given me something. So it's given me cryptocurrency is a scam. It's the biggest Ponzi scheme in history, and it will never work. Okay, you know, uh, the only way to make money with cryptos, you have an account on this website that gives you a Bitcoin address for each transactions, blah blah blah. So it's getting it some jargons from the trained data. The post has been shared more than 10 million times, something that it has seen in the training time, and that's what it's giving you while you are inferencing it. So that's the thing. You can also get this here, to find out. You can see the cached here, so 10 GB is around in the cache, and the allocated like is like 5 GB, which is good. I'm on NVIDIA L4, and you can find out the cache one. Of course, makes it a bit more efficient, guys, to be honest. There's due to ternary accumulations and BitLinear layers, but Can we really use this is the question, and that's I leave up to you. Why? Because you can do a go deep dive and do a bit of research in this topic of MatMul free language model or one bit LLMs and whatnot. You know, that's all for this video, guys. I just wanted to create a cover this up, cover this in a bit detail, the research paper. You can go through it and learn. And if you find this interesting and if you have any findings, let me know in the comment box. And you can also reach out to us through our social media channel. Let me show you guys our Discord community. We already have 400 people, near to 400 people in this Discord community. I will give the link in description of this Discord, and you can see we do a lot of things. We are having job openings, job updates. You can see we have posted some job updates over here. You can see, and then you know uh, we have our development updates, we have sponsors chat, we have partners chat, we have stakeholders. So if you are some leaders and CXOs in some organizations, you can participate in this stakeholders chat. We kind of have a partners chat if you want to partner with us, the open source community that we are building at AI Anytime. We have a global chat where we help each other, we kind of discuss a lot of things. We have leaderboards where we also do giveaways. We have already announced two giveaways. One is the Discord Nitro and the other is limited edition AI Anytime merchandise. You can see these guys are leading. We also have a memes thing, so memes. Without memes we don't believe without memes doing things. And then we also do hackathons. You can see a lot of hackathons have been announced in the community. You can participate in these hackathons. We also have a project showcase where you can show your project. You can see we have project, the best project wins some perks, merchandise, and whatnot. We have help channel where you can talk about how to solve a problem, how to solve a given problem. You can see the guys help each other, and these are all great guys. You can learn a lot from all of these guys here. And then you have the help data science channel. We do town halls every weekend when we get time. We discuss, we do real coding jamming sessions. We do a lot of things, we discuss. Join this community, guys. There are a lot of things waiting for you here in the community. Yeah, that's all for this video, guys. I hope you like the video. If you like the video, hit the like icon. If you haven't subscribed the channel yet, please do subscribe the channel. That motivates me to create more such videos in near future. Thank you so much for watching. See you in the next one.